Here's another example where we have to find the absolute max and min, and keep in mind on this problem the interval is 0 to infinity. There are parentheses at 0 and infinity, so this is an open interval. So we cannot use the extreme value theorem on this problem, so we'll just have to do it the old-fashioned way, find the derivative, critical numbers, then draw the line and decide from the line. So the function f of x is equal to 5x plus 20 over x. The 20 over x is written in a bad way. I cannot differentiate it right now, so let me spend some time rewriting the problem. So 5x plus 20x to the power of -1. So I'm using an exponent rule that says a to the m on the denominator of something is the same thing as saying a to the negative m on the numerator. So having a negative in the exponent just means that you are supposed to be on the opposite side of the fraction. So that's what I'm using to rewrite the problem. So now that I have this, I'm going to go ahead and find the derivative, f prime of x. The derivative of 5x is going to be 5. Derivative of 20x to the -1, we bring the power down. -1 times 20 is going to be -20. Then we subtract 1 from the power, so it's already a -1. When you take away another -1, the total is going to be -2. And this is the same thing as saying 5 minus 20 over x squared. Let's put it together in one fraction, and that will give us 5x squared minus 20 over x squared. If we factor 5, we get x squared minus 4, all divided by x squared, which now means we already find what makes the derivative equal to 0. So it's equal to 0 when the numerator of the fraction is equal to 0. So when all of these guys right here are equal to 0, that's when we get the derivative to be equal to 0. So the derivative equal to 0 when x squared minus 4 equal to 0. I drop the 5 instantly because 5 itself can never be 0. And this x squared minus 4 will be 0 when either x is going to be 2 or x is going to be -2. Okay, I did kind of factoring in mentally. X minus 2, x plus 2 equal to 0, which means x is going to be 2 and x is going to be -2. Those are my critical numbers, and that's basically the end of the first half of the problem. Now we need to know what makes the derivative undefined. So when is f prime of x undefined? And it will be undefined when the denominator is itself equal to 0. So the denominator x squared has to be 0 for the function to be, for the derivative rather, to be undefined. Okay, so that's the step right there. So this happens when x squared is equal to 0, i.e. it happens when x itself is equal to 0. So we have basically so far 3 critical numbers. And you know, we're gonna try to decide whether they fit inside the interval or not. So far these two work. Well, no, never mind. The -2 does not work. It's not between 0 and infinity. And also 0 is not going to work because it is not allowed in the interval. They put a parentheses, they did not put a bracket there. So what does that mean? That means we're going to be doing the f prime test. However, instead of going -infinity, +infinity, we're going to start with 0, but we're going to put an open parentheses right there, meaning don't test 0 itself and don't decide if 0 is a maximum or minimum. The only number that works in this problem is going to be 2. That was the only critical number that was left that works for my interval. And pick a number before and pick a number after. Let's say I pick 1 and 10. If I put 1 into the derivative, I'm going to get a negative amount at the end. So that means minus is going to be shown up first. When I put in 10, I'm going to get a positive amount. So that means the function decreases, then increases, which means that 2 is going to be a minimum. And it's the only one on the whole problem, so we're going to call it an absolute minimum because it was the only one in the problem. Okay, take a look at the next problem and see if you can get the answer, and I'll give you the solution in this video in a minute. So pause the video, find out if the answer matches with mine. So here's what I got for my next problem. So I started off by saying to myself, I really don't want to do a quotient rule on this problem. So I decided to rewrite it by splitting the fraction into multiple pieces and reducing the fractions to lowest terms. Once I did that, I was able to find the derivative and then setting it equal to 0, find out what makes it undefined, kind of similar to the last problem that I showed you in the same video. And turns out that 3 was the only critical number that works for my interval. So 3 at the end is going to be the only absolute minimum because it was the only minimum in the problem, or the only maximum. It's the only extrema really. So automatically that's labeled as an absolute.